Kia ora team, I hope you're all doing okay. Just let me know if the sound is working all goods, and we'll make a bit of a start. Hopefully everything is coming through okay. Just sign off in the chat if you join a little bit later on so I know that you're here. Our plan for today is we'll actually keep this one pretty short. All we need to have a talk about is the last concept we were missing from acids and bases. Which was rates of reactions. So we're going to have a little bit of a korero about that today, and then I'll tell you about our plan for this week, and then I'll leave you to do all the important work that I'm sure you've got piling up. Hopefully, science keeps things reasonably chill, but you can give me some feedback on that either today or you can give it to me when we have our Google Meet later this week. I can see a few more of you joining in. Kia ora, Simon, kia ora, mahig. So just keep signing off as you join in. All right? Okay, and at any point, you're welcome to pause the video and review the concepts that we're going through, or you can come back and view the VOD after it's uploaded. Okay? All right, let's make a bit of a start. So, the rate of a reaction, what does that mean? Well, that basically means how quickly a reaction happens. So you could think about it, if I dropped in a piece of magnesium metal into some hydrochloric acid, we'd see some bubbles coming off, and those bubbles would be hydrogen gas, and we could test that by doing a hydrogen pop test. Now my hope is that when we end up back in the classroom, we will have done all of our content learning and we can just do a whole bunch of experiments, which will be quite fun. But you can imagine that sometimes you could change certain things and that would speed up how quickly that reaction happens. Now, it doesn't all happen all at once, does it? If you drop in a little piece of magnesium metal into a hydrochloric acid, it doesn't all immediately turn into hydrogen gas and immediately turn into the salt that's left over, does it? No, you've got the slow process that happens, and there's a few things that can affect it. So we can speed up or slow down that reaction. That's what we're talking about today. Now, there are four main groups of things that can affect reactions, and we need to know all of them. In terms of increasing the rate of reaction, things that can do this are increasing the concentration of a solution. So that might be increasing the concentration of the acid, making it stronger. It could be increasing the surface area of a solid. So that would be like increasing the surface area of the magnesium there, for example. It could be heating up the reaction, heating up the tube that you're doing the reaction in, or adding what we call a catalyst. So we're going to go through these one by one, and that's going to be our focus. Now, while we're doing this, if you have any questions, you can fire them off in the chat, and I'll be flicking over from time to time, and so I can try and answer those live while we're going through those, if you've got any partai, any questions that are coming up. All right? Okay, let's talk about the first thing that affects reactions, and that is catalysts. So the classic example of a catalyst is elephant's toothpaste. So elephant toothpaste is a beautiful little experiment, and it's a decomposition reaction. So it's where a compound breaks down into some other parts. Now normally H2O2 or I've forgotten the name for this, but H2O2 is a beautiful little compound that spontaneously decomposes into water and oxygen gas. Now you wouldn't want to drink any of this stuff. Hydrogen peroxide, I think is, yeah, hydrogen peroxide. Now you wouldn't want to drink that because then that decomposition would happen inside of you, and that would be awfully not so good. So hydrogen peroxide is actually not a super stable chemical, reacts with lots of things, but it even just on its own will decompose naturally into those other components. Now normally this is quite a slow process. So if you leave a container of hydrogen peroxide for a while, eventually all the hydrogen peroxide will break down into water and into oxygen gas. And it does that quite slowly. But you can speed that up by adding a surface, essentially, for this reaction to take place, for this decomposition to occur. There's a few different catalysts that work. Yeast actually works quite well, but from memory, copper works quite well too. So what you can do is you can add this catalyst and speed up the reaction. Now, for an effect, what people do is they put in a little bit of dishwashing liquid and some food colouring, and the dishwashing liquid and food colouring capture those bubbles of oxygen gas as they're forming. And so if you put it in a little beaker, like is shown here, then the rapid rate of that reaction occurring once you've added the catalyst, that rapid reaction occurs all at once and can generate a huge amount of pressure and fire it up into the air. So that's quite a nice little one there. The way that catalysts do this is they lower the amount of energy that is needed for that reaction to happen, right? That means that each of those particles that are bumping around into each other are way more likely to undergo the reaction. Another way of phrasing this, we would say that the probability of a successful collision is more likely, right? And that increases how quickly the reaction happens, and that's why we add catalysts to reactions. Other examples of catalysts include the enzymes in your body. So enzymes are little molecular machines, and those little molecular machines do jobs around the body. For example, turning in plants, turning sugars into starches. So that's what catalysts do, and they speed up how quickly those reactions happen. All right. Now I'll just flick over to the chat, see if there's any parts so far. So in regards to your test, which we'll talk about at the end here, so we'll come to that, you will be given, you're more than welcome to use a periodic table, and in the final exam at the end of the year, you'll be given a periodic table. It won't have names of the elements on there, so you will have to know the names for the first 20 elements in the periodic table, as well as those polyatomic ions that we talk about. That's like sulfate and nitrate. So those are the only ones you have to remember for this test. This test will be open book, so you can look them up this time, but when we do our actual one, it'll be closed book and you'll have to remember those off by heart. Okay? It's a good question. So what else increases the rates of reaction? Well, the second thing is concentration. So how concentrated your solutions are greatly impacts how many particles are in the same space, and therefore how likely those collisions are to occur between particles. Because a reaction can't occur unless two particles or multiple particles are in close proximity to one another in order to undergo reactions. They also have to hit with a sufficient amount of energy. So there's kind of two parts to it. So if you have more particles in the same space, there's a greater chance that they'll collide and therefore have a successful reaction. So when we increase the concentration of an acid, for example, we put more particles in the same space. A good example of this would be hydrochloric acid. So when we go back to class, we'll have a look at different what we call moles of hydrochloric acid. And what that really is concentration. How many particles of hydrogen and chloride are present in the water of the acid. You can get things that are 0.5 moles, which isn't super concentrated, all the way up to, say, like 2 moles, which would be 4 times as concentrated as the 0.5 mole solution. And we'll talk about what moles mean at a later stage. You don't really need to know them at this level, but you can just think about it as the number of particles. More particles means more chances that they're going to collide with one another, right? So if you increase the concentration of a solution, you increase the rate of reaction because you're increasing the chances that those particles will collide with one another. So another thing relating to this is surface area. Now, most often for surface area, we're talking about solids. So a good example of this might be something like magnesium, or maybe sodium hydroxide. Any solid, right, when it's just a big block of that solid, all of the stuff on the inside is not going to be able to interact with the other parts of the solution. So for example, if you had sodium chloride, if you had sodium hydroxide and hydrochloric acid, and you had a big block of the stuff, a big block of sodium hydroxide, then your sodium hydroxide little compound in the middle isn't going to be able to access those hydrogen ions in solution, so it won't be reacting. However, if you got out your mortar and pestle and you ground up your sodium hydroxide, all of a sudden, all of those little crooks and crannies all of those little bits on the inside that previously weren't able to be exposed to acid now can be. So by increasing the surface area, you increase how much space there is for those reactions to occur. You've essentially increased the amount of particles that can be exposed to one another, and that's what increases the rate of reaction, right? And a nice way of phrasing it is that you will have more frequent collisions, right? So that's a good way of thinking about it. So more surface area leads to a faster rate of reaction because your collisions can be more frequent. Now the last thing we talk about is temperature, right? We remember from year 9, we have our little particles, right? In cold environments, they kind of shake like this, not that much, right? And they might bounce off one another from time to time, right? But as you increase the heat of a solution, what you're really doing is putting more kinetic energy into the particles. And as you're putting in more energy into those particles, if they hit one another, there's a greater chance that they will hit with sufficient energy to undergo a reaction, right? So by increasing the temperature of many reactions, we increase the chances of successful collisions. There's also more frequent collisions because they're moving more, so they're more likely to bump into other stuff. So if you think about hydrochloric acid and magnesium again, right? If you heat up the hydrochloric acid, all those little hydrogen ions, way more likely to bump into that magnesium and way more likely to bump into the magnesium with enough energy to undergo a successful collision and therefore react, right? So increasing the temperature increases the rate of reaction, right? So those are our 4 things. Just to bring it back to this slide, right? We increase the rate of reaction by increasing the concentration of a solution, right, like an acid, by increasing the surface area of a solid, meaning that there's more of that solid exposed to our solution or whatever it may be in order for the reaction to happen. If we heat it up, those particles have more energy, they're more likely to collide with other things, and when they collide, they'll have more energy, so they're more likely to react successfully. And if we add a catalyst, that lowers the amount of energy that's required in those collisions for a successful reaction to occur. All right? The other thing we need to be doing this week is reviewing the other content we've been learning about, right? So a good way to review, as some of you have mentioned in the chat, is to sing along that song to the first 20 elements. So hydrogen, helium, lithium, beryllium. I'm not going to sing any more unless I get copyright striked and the video gets removed. But you can find that on YouTube and like jam away to that. That's a good way to review. But there's also all those other concepts. Now, fortunately, the beautiful website No Brain Too Small has a summary document where you can kind of go through and say, do I understand each of these key concepts? And if you do, that's fantastic. But if there's bits you need to work on, you can identify those and then review your notes, review the slides, or even go on to Education Perfect and go through the content that you're unsure about, right? So feel free to take a look at those in order to review the concepts that you need to know. Now, what are we doing task-wise this week? Well, we've just gone through the slides, so that's all the concepts you needed to learn this week that are new. Outside of that, I set some EP last week on Friday for you to work on in your own pace, which reviewed some of the concepts we've been going through. And we're having our live stream right now, just going through all of that stuff. We'll also be having a Google Meet on Friday. Now we can do a bit of a Q&A then, so you can ask me any questions. And we'll do a bit of a Kahoot reviewing the concepts we've gone through so far. Now what Ms. Kumar's going to do is on Thursday, we'll be setting up an Education Perfect test. Initially, this test would only be able to be completed on Thursday and Friday, but Ms. Kumar has extended that to Sunday. So you've got until the end of the day, Sunday, to complete this test. It'll take you about an hour, I think, maybe a little bit longer, to do the test, and it's going to be all multi-choice. Because it's all multi-choice, there won't really be an opportunity to test that kind of excellence level thinking knowledge. So the maximum mark you're going to be able to get in this one is a merit, but we'll have another test in the senior exams, right, where you can go for those E-level questions. We're mostly using this as a diagnostic at the end to make sure that we know what we've taught well and what we're going to need to go over a little bit more before you sit those senior exams. Okay? Now, don't stress out too much about this. You can do it in your own time. It will be an open book test. If you want to give yourself a little bit of a challenge, you can do it without an open book. So you can do it without your notes. But it's up to you. My suggestion would be to test yourself um, and really get a grip on what you know and what you don't know. And we will have another opportunity to go through and give you your final assessment on this. Now, this is an external, so this is kind of like a practice assessment. And when we do our mock exams, we'll use those grades in case we end up in another lockdown over the senior exam period, like the actual NCEA exam period. So we still have evidence that we can use to justify what grade you should get if you weren't, say, able to do those exams at the end of the year. All right, so that's basically all I wanted to talk about this week. And that's all over in about 20 minutes. So what I'll do is I'll hang on for a couple of minutes if you want to ask me any questions in the chat. Um, please don't stress too much about this test. It's just looking at what it is you know and trying to figure out how we can teach you better. Okay, and yeah, I'll hang around. If you want to ask any questions, please fire them away. And look after yourselves before next week. I'll hopefully see you on Friday for that Google Meet. But yeah, all right. Have a lovely rest of your day, team. I'll catch you all later.